For the first time ever, C#, .NET running in your browser builds SPA applications using the language that you love with the power of a new technology called Blazor, debugging progressive web apps. You don't want to miss this episode. Hello, and welcome to another episode of On.net. We're continuing our ASP.NET Core series with a special look at a new technology called Blazor. With me today, I have Dan Roth. Dan, welcome.
Thank you. It's great to be here, Jeremy.
That's awesome. Dan, what do you do for Microsoft before we jump into Blazor?
I am a program manager at Microsoft, and I work on the .NET team. I specifically work on ASP.NET. I work on all of the UI web frameworks that we ship, MVC, Razor Pages, and most recently, Blazor.
So it sounds like we have the right person on the show. I've heard a lot of buzz around Blazor, and the elevator pitch, if someone has no clue what it is, what is Blazor?
Blazor is a new web UI framework where you can write your UI using .NET and C# instead of JavaScript. So
we had a show where we talked about ASP.NET MVC, and in that you could use Razor Pages to mix HTML and C#. So how is Blazor different from that?
So MVC and Razor Pages are server-rendered technologies. They run on your server on .NET, typically .NET Core, and they generate responses to requests that get sent by the browser. The browser sends a request, your .NET code generates some HTML and sends that back down to the browser to render. But if you want to do anything client-side in the browser, like run some code on the user's machine, historically there was no way to do that without writing some JavaScript.
Right.
You typically have to pull something in like, Angular, React. In the olden days, it was jQuery. These days, who knows what it is? It could be, I hear Vue is really hot, or Svelte, I think, is one of the new frameworks on the block. You had to use one of these JavaScript frameworks to run code on the user's machine. Blazor completely changes that and makes it possible for you to write your entire app end-to-end, both sides of the wire, using just .NET and C#.
So I think for C# developers, being able to write C# that runs anywhere has been a dream for a long time. And I know I won't mention other technologies that kind of had that promise of writing C# in the browser that we may have gotten excited about. But when we're talking about Blazor, how does Blazor work?
Yeah, so it's there was a previous technology that ran in the browser, .NET, the technology that shall not be named. It was based on a plugin. The thing with Blazor is it is fully based on open web standards. You only need a browser, nothing else, no proprietary plugin in order to get your app to run.
So this is truly cross-platform. It'll run on my phone. It'll run on my tablet without a plugin.
Mobile, desktop, any browser, Windows, Mac, Linux, it will run on all those guys.
Nice.
So how does that work is a very interesting question. There's actually two modes that Blazor apps can run in. We call the first Blazor Server and the second Blazor WebAssembly. Let me show you what those look like.
Okay.
All right, so first, this is what Blazor Server looks like. Blazor Server works by setting up a real-time connection between the browser and the server. Your .NET code still executes on the server. That's where all your UI logic, your UI components run. But using that real-time connection, Blazor is able to manipulate the DOM and handle any UI events from the browser. So it's still code running server-side. You're not actually executing your .NET code on the user's device, but you can still get that rich interactive feel that you would normally expect from a SPA-style application, a single-page app that you would have to write in JavaScript. But here, you can write it all in C#.
Okay.
So that's Blazor Server. The other model that we support, we call Blazor WebAssembly. In a Blazor WebAssembly app, you download with the app a .NET runtime that's implemented in WebAssembly. Now, what is WebAssembly? Well, WebAssembly is actually been around now for quite a few years, but it's an open web standard for a bytecode for the web. It used to be that browsers could only speak JavaScript. Well, now they can speak JavaScript and also WebAssembly. So the idea is that you don't usually write code in WebAssembly. It's a fairly low-level thing, just like you don't typically write in assembly code like for a desktop machine. You take code and compile it to WebAssembly. And as long as you can do that, you can then take that code, compile it to WebAssembly, and run it in any modern browser at near native speeds.
And this is any .NET project that targets, I'm sure it's a specific version or the level of the runtime, but I can literally take a DLL that I build with .NET, write with C# and run it in the browser using this technology.
Yeah, so it supports .NET Standard, .NET Standard 2.1. So any library that works with the API surface area that's available with .NET Standard 2.1 is good to go in a Blazor WebAssembly app, with one constraint, which is that, well, the app's going to run inside the browser security sandbox. So if your library tries to do things that aren't allowed by the sandbox, then the runtime will throw like a not supported exception. So examples would be if you try to arbitrarily touch the file system, or open network connections to random places, or touch the Windows registry. Those aren't things that the browser security sandbox will let you do. So those code paths would throw runtime exceptions. But anything else that can safely run within that sandbox will run just fine.
Sounds great.
Now, the nice thing is that it doesn't really matter which model you pick. Your components that you author with Blazor work the same. Like, it's the same component model regardless of which hosting model you choose. So if you decide to start out with, Blazor Server sounds great, that's what you want to do, and you build a bunch of UI using components in a Blazor Server application, it's running great, but then later you decide, you know what? I really would like to take advantage of the user's device. I want to switch this to be a Blazor WebAssembly app. That's actually very straightforward to do because the component model is exactly the same.
Nice. So I'm not locked into, if I'm writing Blazor, for the most part, I'm writing Blazor. My Razor components, I compose those, and I can plug those in regardless of that hosting model of server or WebAssembly.
That's right.
Awesome.
All right, let's take a look at it now. Let's go look at some code.
All right.
So, cool. So this is a Blazor Server application. This is a little recipe app. Let me go ahead and get it running so we can see what it does. There it goes. While it's getting running, I might as well point out that if you want to get started with Blazor yourself, all you got to do is go to blazor.net, blazor.net. That'll bring you to this Blazor homepage. Just click on Get Started. That'll give you all the instructions on what to do to get set up. You can build your first Blazor app in like 5 minutes. Here's that little recipe site that I built using Blazor. We can do some searches, like, I don't know, let's search for chocolate. And as you can see, as I type, it's filtering down the set of recipes based on the ingredient I typed. We could type strawberries, so we get strawberry recipes. Or something with straw in it, apparently. Straw and hay, fettuccine. That sounds I find this fascinating. I think it's just the way it looks. I don't think it actually has straw in it. Maybe it tastes like straw. I don't know. Well, anyway, then you can click on recipes. You get to the details of the recipe. There's a little review widget also at the bottom, so you can say how much you like this recipe. It tastes great, and submit that, and it updates. And you can see all of this stuff is not doing a full page refresh. It feels like a rich interactive application, but this app is actually a Blazor Server app. So if I take a quick look at the network trace for this application, let me go ahead and refresh it. So we look at the download. So down here, you can see there's this magic _Blazor request, which is a WebSocket request, which is setting up a real-time connection back to the server. And then, like as let me clear the messages that are going across that WebSocket. As I click on things, you can see these little binary messages fly across that connection to the server where my UI code actually lives. And then, love it. Let's type something else and submit. There we go. And then as the components run, they calculate how the UI should be updated. The UI diff gets sent back to the browser and applied to the UI. So that's how this is all functioning. And all of this app is implemented with just C# and .NET. I'll jump over to the code real quick so you can see a little bit what that looks like. This is the main homepage for the app. All the stuff in dark purple, those are UI components. So the search box tag, that's the search box at the top of the app. Let me go back to the home page. So this little widget here is this search box component. So you can encapsulate chunks of UI as custom tags. And then we have a little bit of logic here for rendering all of the recipes. And it's just an HTML unordered list. And we're looping over all the recipes to render list items for each recipe using this recipe card component. Where do those recipes come from? Well, components have a life cycle. So down below, you can see when this home page gets initialized, there's an on-initialized async lifecycle event that gets fired. And we go to our recipe store and get all the data for the recipes that then gets used up above in the UI.
Nice.
So that's a Blazor Server application. This is all running server side, but we can also take a look at the newly released Blazor WebAssembly. So Blazor WebAssembly just became a stable release very, very recently. So let's go ahead and create one of those. I'm going to create a Blazor WebAssembly app from scratch, just so you can see the file new project experience. So if you get the latest Visual Studio 16.6, you can create a Blazor app. Let's go ahead and select that. Blazor App 1 is a perfectly lovely name, and we'll create one of those. And then in the Create a New Blazor App dialog, you can see I have those two choices, Blazor Server or Blazor WebAssembly. For this demo, we're going to do a Blazor WebAssembly app. And we've got a bunch of options that we can choose from. If I select ASP.NET Core Hosted, what does that mean? Well, that means that this Blazor WebAssembly app, yeah, it's going to run client-side in the browser on WebAssembly, but we can also host it so that those static files are being served by an ASP.NET Core application. And now you actually have .NET on both sides of the wire. You can write your UI that runs in the browser in C#, and then you can also build your back-end APIs using .NET and C#. We can also click this Progressive Web App checkbox. What's that? Well, that's going to add some additional content to the project so that this app becomes a full progressive web app that supports things like offline scenarios and being able to install it on the user's machine as a sort of native web application on the device. Progressive web apps are basically web apps that implement additional open web standards that gives them a more native app-like feel.
This is nice. I've implemented progressive web apps in the past, and it wasn't as easy for me as clicking a checkbox.
Yeah, super simple. And then one more checkbox let's check is let's go into the authentication options, and let's go ahead and enable some individual user accounts authentication. This is going to set up our app to also have identity server set up on the server for acquiring tokens that the app can use to authenticate users and authorize access to APIs. So with just a few clicks, we'll go ahead and click Create.
And just to be clear, what it's scaffolding for me now, a Blazor WebAssembly app with an ASP.NET Core host and an identity server. So we're getting basically the application, the connection between the client and the server, and authentication.
Yep.
And a progressive web app. Don't let me forget that.
Progressive web app.
All right.
3 projects in this solution, right? We get the server project, that's the ASP.NET Core app that's going to host the static files that get built out of the Blazor WebAssembly part of the app, which is this client project. This is where my components actually live. Here's the home page, and I got a little counter component that you can click a button and the count goes up. This client project gets built, turned into some static files that then get hosted by the Blazor this server project. The server project has a web API. This is just a normal ASP.NET Core web API for getting some weather forecast data. So we can call this get action to get some data. We're going to use that in the app. And then it also, like you said, it has identity set up. So if we look in the startup code for this project, in here you can see that it is setting up identity server so that we can also log in users, acquire access tokens and identity tokens for handling authentication flows. I'm going to go ahead and hit F5 so we can get this guy running. Now notice that I'm hitting F5. Like I'm going to debug. I'm going to debug .NET code that's running in the browser on a WebAssembly runtime. Like how does that even work? How do you attach a .NET debugger to a runtime that's executing in a browser? Well, we do some very clever stuff where we set up a debug proxy between the browser and Visual Studio, or whatever your debugging client is, that knows how to translate the JavaScript debugging protocol so that it augments it with .NET specific concepts. So if this all works correctly, we should be able to simultaneously not only debug the .NET code on the server, but also the .NET code that's actually executing client-side in the browser. So this browser is being launched with remote debugging enabled, so that Visual Studio can attach to it. If you just give it a second, we should pop up here just a minute. So we got our app running, and there's a little counter here. We can click the counter and it goes up, and that's all cool. Now, if I go back to Solution Explorer, let's go to our counter component. I'm going to set a breakpoint right here on increment count. This is the method that's getting called every time I click. Now, if I click, ta-da! So we just hit a breakpoint in .NET code that's running in the browser on a WebAssembly-based .NET runtime. We can, inspect the content of the current count. We haven't let it continue through yet. So, but if I F10, there, just increment it to 1 and let it run through, and then now the UI updates. Now, if I click on fetch data, well, fetch data is actually a page that requires authorization. So you can see it's bouncing me over to a login page. To make that happen was really easy. The fetch data page just has this single attribute right here, this authorize attribute, just like you would on like an MVC view or a Razor page. And I can set up a user. So I think I have to register a new one. Let's set up a new user. I'm going to put in my favorite password. Register that. So this is just the normal default identity UI that you could use with any of the web apps in ASP.NET Core. It's backed by a full database, and in this case, it's also integrated with Identity Server. Now, I haven't set up the identity database yet, so I'll apply migrations by just clicking the button. And then after a second, that should say it's done.
I like how it's cautiously optimistic that clicking this button may resolve the issue.
That's right. All right, and now normally you would have like an email confirmation flow right here. I'm just going to click here to confirm, and now I should be able to successfully log in with my account and hopefully get to my highly protected weather forecast information in my Blazor WebAssembly app. There it is. So now this actually called the server, like it made a web API call to that weather forecast API that we saw previously. And it only allowed me to do that now because I'm actually logged in. So if let's do one thing here. If I go back, I'm going to go to fetch data. Down here in the onInitialized async method, that's where we're making the call to the server. So you can see there's that HTTP get from JSON async, like pulling down the JSON data. I'm going to set a breakpoint on the client. And then I'm going to go to the server, to the API, and set a breakpoint on the controller action that's returning the data. And then back in fetch data, let's just set a breakpoint after it's done so that we know that we came back. All right. And so to trigger that, all I should need to do is go to fetch data. And you can see we hit the breakpoint in the WebAssembly-based code. This is running in the browser. We're in F5. So now we're hit the breakpoint on the server. So we're doing end-to-end debugging of the client and the server. And we can step through, our server code and see how that goes. F5 again, and we come back to the client, and we've got our weather forecast array. And now if we F5, we should be good to go. So there's end-to-end debugging with authentication all wired up. The last thing I want to show is that you'll notice that there's this like plus button in Edge at the top. What is that? Well, Edge has detected that this app is a PWA, and so it can be installed on the local machine. If I click that and say, yeah, do I want to install Blazor App 1? Sure, go ahead. Now I'm getting like a native Chrome around my web application as if it's a native app running on Windows 10, but all the same functionality is there. Yeah, I can hit my breakpoints again. I should probably clear those out. There we go. Like all the same functionality works. And the reason why this is supported is because by clicking that progressive web app checkbox, our application got set up with a couple of additional things. So we got this manifest file and an icon so that the operating system knows that, oh, I can make this installable. Like if I want to put this in the start menu, now I have a Blazor App 1 icon sitting in the start menu that I can use to launch that application. Also, it has a service worker. And this is a little bit of JavaScript. And I know you said you didn't have to write JavaScript, but this JavaScript is kind of a pre-canned thing that we just give to you. Here it is. This JavaScript basically handles caching all of the files needed to run the app locally on the user's machine so that you can support offline scenarios without having to go back to the network to make the app execute.
And hopefully I don't have to deal with this JavaScript. It's just handed to me from the template. So unless anything needs to be customized or changed, we're off to the races.
Yeah, that's true. I mean, we do set you up with the most common, cache first scenario for service workers for PWAs. If you want to implement a different pattern, like a network first or whatever, typically what you end up doing is you search on the web, you find a recipe for a service worker, copy paste, and then use that. Most of the time, the service worker code is pretty pre-canned.
Yep.
There's a PWA with authentication and debugging, all with Blazor WebAssembly.
That certainly checked all the boxes. That was an exciting demo because it's really the first time I think we can truly have that experience of using the language that we love, C#, the framework we love, .net, and use it not just in the browser and the server at the same time, but that debug experience that goes seamlessly between the two is going to be incredibly useful to people building apps.
Hopefully it'll make writing web apps that much more productive and that much more fun.
Awesome. Thank you so much for your time. This was fantastic. Hi, I'm Jeremy Lickness. You've watched another episode of On.net. Thank you for joining us. Be sure to like and subscribe so that you don't miss a show. And if you're interested in more shows, check out the link right here. Thanks.